Welcome to Sartor TV. I'm Tracy Fitzpatrick. Our studio guest is Dartmouth professor Richard Devaney, who ranks among the top 50 management thinkers in the world. He's also a prolific author and is here to discuss his topical new book, The Pan-Industrial Revolution: How New Manufacturing Titans Will Transform the World. Richard, thanks for being here.
Yeah, thank you very much, Tracy. I'm glad to be here.
Let's get into some personal things about you. You do have a law degree, and at one point you practiced corporate and tax law. Was this the beginning of you starting to think strategically about business and corporations, say, operating more efficiently and competitively?
Well, law kind of led me to a job, which then got me to start thinking strategically. I basically was a tax attorney and accountant, and I financed hotels mainly in Boston. And so I had to write up prospectuses for, for private placements. And there was always a strategy section. Why is this building going to make money? And I found that I wrote those and I delegated everything out to other people who ran the numbers, because I didn't enjoy doing it. And at the end of the day, I just said, hey, forget about this. I need to go. Yeah, I need to go. And then I went back to get a PhD and started all over again, at which time my father told me that I was an idiot.
Wow, okay, good role model, huh?
Well, yeah, he said, your wife is going to divorce you, you're going to be a college professor, you'll never make any money, and so forth.
You are now currently, and you have for the past 30 plus years, as we talked earlier, teaching at Dartmouth College on topics of strategy, management, strategic capitalism. Are these areas that can be taught, or is being a strategic manager in a capitalist society more of something that you just have to know innately? What do you tell your students?
Well, I tell them one thing, but I believe something different, because I tell them we can teach them, otherwise we don't have a reason for them to come here. Yeah, exactly. But the truth is that it's more innate. You have a feel for how power gets used and how to take the learning from, watching football to business to military, and there's some kind of principles underneath all of that for the large-scale application of power.
Teaching is considered one way of spreading your knowledge as an expert, but you also consult, here's a long list of things, again, individuals, teams, corporations, military, governments, and capitalist systems, among others. What exactly is your mission?
For me personally, or
business,
for them?
Personally, let's talk about the business angle of it.
Yeah, the business angle is really, I want to make a difference. And I want to espouse a way of thinking that's always counter the norm and more effective as a result of that. So I try to get people to see things from a different perspective.
Out of your strategic management pursuits, you seem to have centered yourself on the concept of technological competition. Explain what this is all about.
Yeah. Well, my progression over time was different kinds of competition, and now I've finally reached the technology side, because that's the critical thing of the future. 3D printing and additive manufacturing, kind of a broader category of than just 3D printing. These things are about to change the whole world. And Henry Ford is dead. Henry Ford is getting deader every day, if you can put it like that. This is all about, how is society, how are corporations going to change, how will supply chains differ, how will organizations differ because of this new technology.
So do you think 3D printing is going to be the next disruptor, say like the iPhone was back in 2008? I mean,
much bigger.
So real?
Yeah, much bigger. I think what most people don't realize is that we're at an inflection point in world history and in civilization that's equivalent to the 1890s to like 1910. During that time period, everything changed. Cities got built up, people moved off the farms, alienation took place, and unions started to come into play. Lots of immigrant labor was able to be used in these factories, just endless numbers of things. And then, of course, with the assembly line in the car, it became affordable. to own these things. And so now we had roads suddenly being built and horses disappearing and people able to take longer distance trips now and suburbs growing up and so forth. So all of this stuff changed, and we could go on for 2 days. I don't want to bore you with it all. But we have the same kind of change going on now on the technology of manufacturing that happened due to Henry Ford and all of his colleagues from that era. And as a result, just thinking about how this is going to affect all of us is mind-boggling.
So your work is also focused more recently on the emerging world of 3D printing, which we have been talking about. And your new book is called The Pan-Industrial Revolution, How New Manufacturing Titans Will Transform the World. What is this book all about, and what made you decide to write it now?
In a nutshell, when you look at firms using additive manufacturing, they have incredible flexibility. So they don't have to make the same product from day to day to day to day, or even from minute to minute, unlike our regular manufacturing. So conventional manufacturing leads to a world of economies of scale, but the new world will allow economies of scope, which will allow vast kinds of diversification that we never thought was possible. And so let me leave you with a question. What do you call a firm that 1 minute makes a bicycle part, half an hour later it makes automobile parts, 3 hours later it's making, let's say, ship parts, 4 hours later it's making drones, all using additive manufacturing, and it's endless how much you can make with these kind of, with 3D printers. So as the printers get better, firms are going to no longer have an industry, and hence the word pan-industrial. The firms will become spread across multiple industries rather than have an industry focus. And all the industries that we know of are going to disappear because of that. The General Motors won't be a car company anymore. And when they finally full-fledged get into this, they'll be making so many different things at the same time that they won't be General Motors, they'll be General Metals. So anything made out of metal will come out of it.
And the cost will remain low because of this 3D technology.
Yeah,
So,
the 3D.
which is something companies cannot do now, do a million things at once and be profitable.
It's impossible now, because right now with conventional manufacturing you have to make a new mold, and that takes 3 or 4 months and thousands of dollars, and then you have to shut down your line and change it over. With 3D printing, you simply download a different file into it with the design that you want made, and it prints it out. There's no changeover, there's no molds, there's nothing that would get in your way for immediate switching. So the flexibility of this process is just beyond belief.
Why has 3D printing become such a hot topic and concept now? Has it been in the works for, say, a decade, and now it's coming into its own? Explain it.
Yeah, well, actually, we've used additive methods back to the ancient Egyptians, where they built things in layers, and it was basically an additive process. But what's happened over time is 3D printing moved its way into prototyping. But in the last 2 years, a whole bunch of new methods and new companies have jumped into the ring, and they're able to mass produce at costs that are less than conventional costs. So suddenly we now find companies like Hewlett-Packard in the business, and they introduced their first printer last year, and they jumped to the number 3 producer within 1 year because their machines are so much superior and so much faster and better quality than the current ones, and they're making them even faster and lower cost producing equipment now than they did 1 year ago. So this is a kind of technology that was a Moore's law, where the costs are very high, and then they come down, and then they start to really drop steeply every time the next generation comes out. And I think that's why we're seeing the jump, because we hit that point that tipping point in the last 2 years.
So what does the competitive strategy look like for a 3D printing company? Is it going to be building bigger, better, more type of objects, more useful applications, or all of the above? Is it just going to be a conglomeration of everything
You
could think of?
You can do anything you want with the 3D printing. You can make things more precise or less precise. You can make things more porous or less porous. So the pores affect the strength of the product that you're making and the water absorption of the. So some things you want to absorb water and other things you don't. And you can adjust that. There's even developments now, they're not commercialized yet, but there's even developments now where they use photons to be able to move atoms around and structure the metal or the plastic in exactly the way you want to get whatever product properties you want from it. And that's pretty amazing. I mean, we're starting to get to Westworld here. And yeah.
What are the challenges facing 3D companies right now, and are those challenges, you think, going to be mirrored within other industries?
Yeah, well, 3D printing companies kind of break down into two groups, the users and the producers, the ones who actually make the printers themselves. And of course, they're highly interconnected. The better these guys do at making better machines, the more the users use them. Right now, there's a lot of resistance because all the engineers don't know how to design for 3D printing. You can make things that you couldn't imagine before with such intricacy and complexity that you were unable to do things. So engineers, like to stick with what they know, and so there's a lot of resistance to switch over.
So how about at Dartmouth? Are you teaching courses on this now so that there will be skilled people, next generation to?
Yes, well, I teach in the business school, so I teach my students as part of my competitive strategy course, a module in there about the competitive strategies associated with 3D printing. And I just wrote an HBR article on 3D printing business models. So I'm trying to disseminate what I know in multiple channels. So I do teach them. I don't believe we have anybody in the engineering school that's teaching the 3D printing techniques. But I do know that the workshop in the engineering school has just put in a big order for a large number of different kinds of printers. So that tells me that they're planning to introduce courses on that.
How do you fight the idea that 3D printing is just another fad, or worse, that it's a tool that can be used in a negative way, which we saw recently in the news with the person who wanted to create guns from it? What are your thoughts on that?
Like every technology, it can be used for good or for evil, right? And but I think overall the net is going to be very positive. Let's deal with guns for a minute. The guns are a very, very small part of the industry right now. And I believe that the strategy that's going to happen is that firms are going to keep expanding and expanding and expanding until we end up with these very, very large titans of manufacturing. And those firms are going to create a network, like an ecosystem of other players that attach to them. And the competition is going to move between this group of firms to that group of firms. And as a consequence, they're all going to get together, because there's only going to be a small number of them, and they're going to pressure the printer makers to create printers that won't print out guns, and they won't print out gun parts. That's what I believe. They'll set standards, and the machine will just turn off. Or if they see a file being downloaded, it'll be an endless battle back and forth. The key.
There's always ways to get around technology, though, right? There's always a back door somewhere.
Yeah, if anything we've proven is no rule ever works, right? There's always a way around the laws, even if the government doesn't accept that. and people are always cutting fine edges. So but the average citizen won't go through all of that. It's too much trouble, and they don't want to, hire lawyers and all the rest of this stuff to defend themselves. It's going to be the terrorists and the criminals that want to do this kind of thing. And we're going to have to monitor usage of the machines. And in one way, if they're making stuff and it's monitored and reported back to the original company, we're going to be able to catch them faster. And in addition to that, these big giant groups, let's say United Metals, Universal Metals, they'll probably have a gun manufacturer in there. So the whole group will have an interest to pressure the government to do all kinds of regulations and so forth. Now, we already do that with guns, but they still get out on the streets, and the illegal ones are still around. In the end, it'll be, like fighting the endless drug war that we have now.
So what do you see as the strategy for the growth and universal applications of 3D printing?
Well, I think the growth right now is going to be in metals. And there's a number of new companies that have just started up and become unicorns, billion-dollar valuations that are like Desktop Metals just outside of Boston. And these folks are cracking the methods of printing with more standardized metals, not the high-end stuff that GE does or for aviation and military equipment, but stuff you do for a bicycle or for an automobile or metal fences and things like that. And so the result is those are going to capture and create a lot of growth. It may not create a lot of jobs, but it'll the net number of jobs will probably go down, but the quality of jobs will go up. Now, what we don't know is whether or not this is going to create other kinds of industries and growth. Let me give you an example. In 2015, I suggested in one of my articles that, with 3D printers, we can make things really intricately. For example, we could make artificial coral reefs and then seed them with sea animals, and that will attract fish and create whole new fisheries. And I got all kinds of notes saying, Devaney, you're an idiot.
You're crazy. Oh,
you've lost your mind here, and so forth. And I just read within the last 6 months that Jacques Cousteau's grandson is experimenting with and building artificial coral reefs.
That exactly thing. Oh,
yeah.
He must have read your article.
Well, I can't say. I can't say. Maybe we parallel processed and to the same conclusion. But think about what that means. So we'll lose a whole bunch of jobs in regular manufacturing, but now with coral reefs, artificial ones, you can create proprietary fish hatcheries. And a food company now can grow a lot more food. We can do in 3 months what it took Mother Nature to do over centuries to build these coral reefs, and we can plant them in waters further north so that the global climate change that's killing off the natural reefs will not reach those folks. So we create a whole bunch of benefits here. First, we feed people better. Second, there's a whole, and we can feed many more people. We can mitigate some of the damages of global warming on the ocean. We can also build food companies, with big floating factories that sit outside of it, freeze the fish, and all the thousands of jobs that will be created selling new frozen fish products.
So it's endless capabilities of what this technology can basically harness.
Exactly, and stuff we never thought. So, we can't even imagine it.
It's exciting.
Yeah, it really is. Because I actually believe it'll solve a lot of the problems that we have. Like, I mean, just as one example was, food and jobs for people who aren't as educated as engineers and so forth.
Companies that are pan-industrial, as defined in your book as global conglomerates that manufacture anytime, anywhere, should that be the goal overall in the 21st century for all industries?
Yes, except there's one more thing I would add to that, and that is that these won't be your father's conglomerates. These will be highly diversified firms with operational synergies. In other words, 3D printers and printing centers will be at the center of them, and the learning from all the different businesses will feed into there, and you'll create a big competitive advantage, and you'll share all of these things because after all, it can print for anybody, for any product you want. And then on top of that, there'll be these industrial platforms that will coordinate all of this. So we're going to end up with another synergy that ties together things more than we do today with the traditional conglomerate form.
So basically, you're saying 3D printing is going to be upend business plans, business philosophies.
Yeah, exactly. Even Wall Street. Yeah. Wall Street right now takes a diversified firm and says we should break it up. But in 10 years, when these conglomerates now have centralized manufacturing and industrial platforms, you can't just pick out one piece and throw it away and break it up because it's highly dependent. And Wall Street's going to have to learn that they can't make, break up these kinds of firms, and that there will be no more conglomerate discount because there will be real and significant operating synergies created by these new technologies.
Okay, so at stake in the pan-industrial business climate is which companies get to dominate the global economy and which ones will fall by the wayside. Is that the correct way of looking at it?
Yes, I think so. I think so. And of course, that means major changes in society. Who's going to end up winning and who's not? And these firms are going to be significantly powerful because they'll be, trillion-dollar firms, and so they're going to influence the government. People will, join one of these companies. In a way, it's a little like moving towards the Japanese zaibatsus before World War II, and you can see how different society was structured because of those. So I'm not sure that that's all good, but it's probably going to be the way it is.
And as we've discussed, you said the competition is already heating up. We've seen big companies like Siemens, GE, United Technology, they're already ratcheting up their 3D capabilities. So do you think smaller startup companies are going to do just as well? Who's going to win that race?
Yeah, it's hard to tell because there's some really great companies like Desktop Metals, for example, or Form Labs, that both of whom are in the Boston area, and both of whom became unicorns. They became billion-dollar valuations, and but the question is whether other big players will come in and club them. So, I always thought GE messed up, and the reason that they're in so much trouble is that they started down the right path building GE Additive, but there were hundreds of more firms that could be bought up. And they could have rolled up that industry and been a dominant player in additive manufacturing, not just in the high-end metals, which they do right now, but also in the regular metals and in plastics. So GE may not do that, but somebody else will.
Right.
And who knows with GE exactly whether they'll be broken up or not. I'm hoping that they won't be and that they can restart on their the journey that they set off.
So can you share a case study with us of a company that's already leveraging and using and gearing up in 3D printing?
Yeah. There's when I went to see this company, I was completely flabbergasted because I had all these visions and I thought I was so far ahead. And then I show up at this company and they're like a year ahead of me.
Of what you were thinking?
Yeah, exactly. And that company is Jabil. It's the number 3 contract manufacturer in the world. They are building an incredible digital platform, and they're the largest purchaser of HP printers, which are very superior, and they have investments in several other printer companies. And they're reforming their entire system to use essentially the things that I said were the core elements of these pan-industrial firms. And they're geniuses at displaying it. I mean, when you walk in, they have like room-sized walls of screens, and you feel like you just walked into NORAD. And it watches the flow of products being made over the whole supply chain.
And where are they based out of? Where are they?
Well, they're, of course, in multiple places, but the headquarters is in Florida. Their main production activity and research activity is in California. And then, of course, they have hundreds of plants all around the world. And I walked in there and I said, wow, better talk to these people.
There you go. Okay, so President Trump has definite ideas on trade and manufacturing, but we haven't heard much from him on this new technology of 3D printing and how quickly it's evolving. As a former business titan, should he be on top of this industry a little bit more? What are your thoughts on that?
Oh, yes. I believe that the key to the balance of power in global geopolitics comes down to 3D printing. And let me tell you why. Rather than antagonizing the Chinese, and having trade wars, if he were to do a Manhattan Project and really push additive manufacturing and the development of new things and the commercialization of it and involve industry in it, he would create a system which, first of all, became not dependent on China anymore, because a lot of the production with additive manufacturing is local. And so we would import the powders and the plastic powders, or we would make those ourselves, and we have most of the metals here available in the U.S. And the plastics, of course, has been one of the places that we shined in the 80s and 90s and early 2000s. So we've got everything we need to build this, and we won't have to buy components in China. They'll simply be 3D printed all together in one item. So one of the great parts about 3D printing is you can combine parts and then reduce assembly, and you build it all at the same time in the same place. So General Electric, for example, they took a turboprop engine with a joint venture partner in Europe, and they reduced it from hundreds of parts down to 12, and using the 3D printing. So no buying components, and the assembly was 12 parts put together. So this allows us to manufacture in the United States because there's almost no labor involved, and it changes the balance of trade and the balance of flow of funds. So the Chinese don't get their continuous inflow of hard currency that they were getting before. And the Chinese start to be in a dilemma, because if they try to keep up with the 3D printing, they're going to have to lay off thousands, or not thousands, millions of people that I don't think they can replace that quickly. Whereas we only have a very small percentage of people that actually make something. When was the last time you drove by a factory? I haven't seen one for ages, except a baby food factory that's not too far from us. But bottom line is that we have a lot of people working for manufacturing companies, but they do design, marketing, branding, distribution, things like that. So we're not going to actually lose that many jobs. The Chinese will lose a lot of jobs, and a lot of these countries that are subservient now in the sphere of influence of China, because they have to sell their raw materials there, will sell us raw materials directly.
So how far into the future are you projecting this? Is this something that we can actually start engaging in now, or is it 5 years down the road? We're still not there yet as far
I
as
would
the technology?
say, you know, this is one of those things where we don't know how steep the Moore's Law is going to be, how fast it goes. But in general...
In your mind, like, what do you think, a decade?
5
to 10 years?
5 to 10 years for some industries, and for other industries it'll take longer. And we have to recognize that, you know, technologies diffuse at different rates. So when the automated loom was invented in the 1830s, I think, even by 1895, there were still people using the old-fashioned looms instead of the automated looms. So nowadays, I think you have to move a little faster, though, because you'll get you'll be sunk if.
Exactly. So, what do you think? What are the 5 myths of 3D printing?
Oh, that's an interesting question. Number one is that 3D printing is mainly for trinkets, junk, plastic stuff that, you know, kids' goofy toys.
You think it needs a new name to make it sound more serious?
Yeah, and that's why people have now started to refer to additive manufacturing, because it's industrial 3D printing. The machines are really different and better and higher quality, and they're more expensive. You know, like some of these metal printers are going to sell for around $1 million, and that's going to be a tough story. You know, when you go home to your spouse and say, "Hun, you know, I bought a new toy to make stuff in the basement. I can make plastic forks for you, and it only cost me $1 million." So that's one myth. Another myth is that it's going to destroy a lot of jobs, because we don't know for sure how many it'll create, like in the fishing and frozen food industries. And there's so many things that are just unimaginable from this. So we don't really know. Third, some people would disagree with me, but I still hold my ground on this, that 3D printing is not about customization. Everybody thinks we're going to make everything exactly to what you want.
Oh, but you can, as far in the fashion realm. That's what it's being used for, correct?
Yeah, I mean, people are trying to do it in all kinds of things, like running shoes and so forth and so on. The problem with this is, with mass customization, is for most products, you know, you give instructions to people, and what you get back is not what you imagined. And so most people will be upset with the customization they get, because it doesn't match up. So now you have to set up a system which collects a lot more information on the way in, which is costly. And then after the product comes out, you have to iterate and say, well, geez, I didn't like this buckle, or I want to change that button, and this color purple just didn't feel imperial enough for me, and blah, 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 blah. So customization, I believe, fundamentally is going to fail, and because it's just such a pain in the neck. And you know, when I tell you I like brown shoes, you may envision whole different colors of brown than I did. So we get all kinds of problems like that, and in the end, it's not going to be customization. What I think we're going to see is some other business models, which I label as mass variety. And this is an example that actually happens. There's a jewelry manufacturer who makes like thousands of rings, but not to your taste. They print them up, and they make kind of a faux version of it. You can see what it looks like and feel it, and it's faux gold, and it's hollow inside. And so a retailer can have a really vast amount of things, and you have to pick amongst them. So it's not exactly what you wanted, but you can get something that's pretty close. You know, maybe the dragon on your necklace doesn't have its tongue sticking out, and you want that, you might not get it. But it'll be relatively close. And then you pick your order, and then it gets manufactured with real gold and solid and so forth. And that'll be not customization, because they're all pre-designed, but it'll be close enough for most people. And then where there's another kind of business model that I'm seeing emerge that I call mass segmentation, and that's running kind of batches at a larger number for subsegments of the consumers. And so you have to buy within that constraint, and the constraints of, this is the mom's version, this is the creepy kid on the street corner version, and this is the preppy look and so forth. And that's going to be more effective, I think, than ultimately having to argue with half the customers who are going to say, that's not what I wanted.
So what's next? Will 3D printing have a shelf life, say, like our dearly departed VCRs, our Walkman, even our desktop computers?
Well,
see
yeah,
the demise?
I mean, everything sooner or later gets obsoleted. And there are new kinds of 3D printing that are coming out that could eliminate the need for some of the other ones. Let me give you an example. Right now, all the 3D printing methods, or almost all of them, are based on putting down layers. And the layers build up and build up and build up until you get something in 3 dimensions. It's like Xeroxing something over and over and over again, and the ink starts to build up. But there are 2 things that we're starting to see inklings of that are able to be additive manufacturing without 3D printing, even though some of them are still called 3D printing. And one of them is called monolithic printing. And this is Carbon makes a machine with a technology that's colloquially known as CLIP. And it's a continuous liquid image projection. And basically, there's no layers. The layers are so instantaneous and thin, they literally just like pull something out of a pool of resin. Instead of having to stop and wait for each layer to dry and so forth. They're so thin that they dry instantaneously, and the light flashes more like a movie rather than a series of flashes like this, and it hardens the resin into an object. So there'll be more and more of those things, and they save a tremendous amount of time because you don't have to stop between every layer to let it harden. So that's one thing that will be an additive manufacturing method that will replace printing methods. And then we have something else that we're already seeing early stages of. It's not used for production by any means. This is self-assembly. I saw something in at Xerox once that just completely made my eyes pop out. They had taken old computer chips and cut them up with lasers into tiny, what they call chiplets. They put them in a bottle, in like a beaker of fluid, and stirred them up. And then before my eyes, the chiplets all started to rearrange themselves and form new chips. And then they sealed all the little pieces together with some light that took the little plastic ends and melted it just enough so that they'd get sticky. And I looked at it and I said, well, how did, this is magic. How did this happen?
Yeah, was it an accident and it worked? One of those things that they're just trying to get another outcome?
No, I think they were so smart that they came up with this on their own. And they used electric current. And they charged the chips, the chiplets rather, with different kinds of current, different kinds of charges. And then the electric current was run through the beaker, and that forced things to attract to each other. And I've read about people using magnetism the same way. So we'll get to a point where we just throw the pieces into a jar, and the pieces self-assemble. And there's another version.
And they're good as new?
Well, at this point, no. At this point, it's still early development. We're talking about stuff 40 years from now. But you asked the long-term question. And then the other amazing one is called 4D printing. And the fourth D is time. And at MIT, they have a whole lab developing this stuff. And what they do is they put materials, and they and the material folds up like origami, and it forms all kinds of different objects. So what you get out of the printer is a flat piece, and then of let's say metal, and then you see they put down kind of little strips of materials that react to light or heat or water, and then they ship it flat, and then you bring it to home flat, and you spray water on it, and you've got a lawn chair. And I mean,
amazing.
Yeah, I know. It's crazy. Or you put it under hot light. Again, no one's using this for manufacturing, but you can see all the savings
But it's out
that
there,
are
it's
involved
coming,
here.
it's on the horizon.
Yeah, and who knows how fast. It depends on how fast MIT is, and I've learned never to underestimate
Never
them.
underestimate. What's your advice for anyone that wants to become an industry titan, whether it's 3D printing or in another industry? Words of wisdom from you, Professor.
It's going to be about being flexible and continuous learning. And some of what's in Sader's book is, exactly what people need to learn. And it's not going to be just people, but whole organizations. And building the right culture for that is going to be important, because people are going to have to give up what they thought was science. These engineers that can design for conventional machines, you should see the stuff that gets designed on 3D printers. Instead of girders holding up things with boxy kind of structures, the girders, now the new structure is more organic, and things are bent around, and it looks twisted, and you look at it and you say, geez, I would never have thought of that.
So what would you personally want to create or invent if you were allowed to with 3D printing?
One of the places where 3D printing is lagging is in bioprinting, like making organs. And what I would wish for the world is that we could improve that much faster than it's doing right now. And the reason for that is that there are people who get emphysema, replace their lungs. Kidney disease and cirrhosis of the liver, replace them. Now, some people would find that very controversial because it's borderline Frankenstein. And Mary Shelley would be very happy to have predicted that. But we're nowhere close to that. We can right now make skin equivalents and skin patches for wounds, and we can make very simple organs like a gallbladder, where it's basically just a bag, or like a balloon with a thin layer of stuff around it. And but we haven't really tested those gallbladders and things like that on people yet. They're still working with pigs and other animals. But the skin, the Defense Department has been putting that and pushing that, because if you can produce something which literally prints out the skin onto a soldier right after they're burned, it solves, it reduces the pain, reduces the infection possibility, enhances the long-term recovery of the patient. So we're experimenting with people all the time, we, not meaning me, but we as a society. And so I'd like to see this bioprinting being invested in more. But it's turning out to be a lot more complicated than people thought. It's not like printing even an automobile. It's way more complex.
Well, Richard Devaney, it's been fascinating and fun talking with you today about your take on 3D printing. Thanks for being here.
Oh, my pleasure. Thank you for having me. I enjoyed it myself.
And that does it for this edition of Sartor TV. We hope you enjoyed and learned something new today. Until next time, I'm Tracy Fitzpatrick. Thanks for watching.